Welcome everyone to our NSC Tech Talk series. I am David Love. I'm professor of electrical and computer engineering at Purdue, and I am also a member of the Executive Committee of the National Spectrum Consortium. Today's Tech Talk is entitled Artificial Intelligence and Network Design. Before I turn it over to our moderator, I would like to say a little bit about NSC. We are a 440 plus member organization working with the government and each other to incubate, accelerate, and operationalize revolutionary advances in technology and to inform the policies that make these advances possible. We do this in a collaborative manner. For example, with non-terrestrial networks, we have established a government, industry, academia working group to identify and provide recommendations on some of the most meaningful challenges in the space. Feel free to reach out to me or another XCOM member if you're interested in learning more about NSC or about the working groups. With that said, let me turn it over to our moderator, Paul Kirby, who is the senior editor at TR Daily, a great resource to anyone interested in telecom, the FCC, or spectrum.
Thanks very much, and welcome to everyone today. We're going to talk about AI and network design and learn about the benefits and challenges of deploying AI in that area. We have two great speakers today. We have Arthur Brisebois, and he is a distinguished engineer at Ericsson. And we have K.P. Suba, her last name is Subbalakshmi, and she is founding director of the Stevens Institute for Artificial Intelligence. We had one other speaker, Paul Kirby, and he was chief technology officer for Data Robot, and he was not able to join us today. So first, we're going to start off with our speakers just to give them a few minutes to discuss AI kind of in general terms, and then we're going to ask them some questions. Please be thinking about your questions, and if you look on the right side of your screen, there's a little box there, and you can click under chat, and you can type in your questions, and we will we'll follow those questions with them and get them answered during our time here. So let's ask Suba first to give us some opening remarks, and then we'll go to Art.
Thank you, Paul. I am Subbalakshmi. I'm a professor at the Electrical and Computer Engineering at Stevens Institute of Technology. And I'm also the founding director of Stevens Institute for Artificial Intelligence. So my own interest in AI in general is on explainable AI / interpretable AI. I make a distinction between these two things. By interpretable AI, I mean AI that is by design interpretable, meaning there are components in it already that will not only give you the final answer for whatever it is that you're designing it, but also to give you a peek into why it came up with that decision. Explainable AI, I think of it more as a sort of post-facto explanation. So the AI engine that is doing whatever you ask it to do does its thing, but the explaining part of it happens after post-facto. So things like Shapley and so on are prime examples of that kind of work. So within the AI in networking and spectrum kind of area, I am interested in AI at the edge, so at the edge network. I'm interested in figuring out how we can better predict the traffic situations, how we can better predict the general quality of service metrics, and how you might proactively change whatever parameters that need changing on the network. So things of interest are using explainability / interpretability as a diagnostic tool, as in to figure out why exactly did XYZ performance happen, and how can you go back and fix the design / other issues within the network. I also am interested generally in federated learning, where you can basically distribute this learning across nodes, especially useful in things like spectrum sensing, where you don't really want to use, you don't want every node doing the sensing independently and then sharing all of that information to a central server. How can you learn so that each of the nodes has its own picture, but they all collaborate together to get the full picture of the spectrum occupancy and so on and so forth. I'm also interested in security-related questions within this area.
Thank you. Art, can you give us a sense of your interests?
Sure, I'm Arthur Brisebois, and my background is currently I'm in the Ericsson Artificial Intelligence Accelerator team. But before that, for 28 years at AT&T, my teams were responsible for the introduction and optimization of new radio technologies on the AT&T network. And before that, I was in the Air National Guard, where we configured combat communications radios in the field. And both of those experiences, I think, have driven a lot of my interest in artificial intelligence. In the cellular network perspective, we were building these very complex networks that had many interactions that were very difficult to manage manually, lots of data from lots of sources. And we did the best we could with manual optimization and manual configuration and integration. But there was lots of opportunity for automation and improvement. So through that whole tenure, we were brainstorming and inventing ideas for automation that we later on found out that what we called learning was really part of artificial intelligence. And in the Air National Guard, we would actually deploy small radio networks over weekends. We would truck it all up to one location on a Saturday, get it working, get it running and optimized, and tear it down Sunday morning and bring it back to base. So in effect, we were creating these small networks over a weekend, and it's a very different planning scenario compared to cellular networks, which in some cases a cell site might not be on air until 2 years after it was designed and conceived. So those two experiences revealed to me and the teams I worked with the opportunities for automation and also opportunities for learning. So what was learned in one deployment, for example, in the National Guard, needed some way to transfer what was learned in one deployment for the next deployment. What was learned deploying a new 4G or 5G cell site for AT&T was needed to improve the deployment of the next cell site or the next city for AT&T. And using humans to manually do these things and document lessons learned and golden standards and all of that was very limiting. So my interest has been in the areas of federation. For example, taking models learned in one cell site to benefit another cell site. In reinforcement learning, since deploying new technologies involves the creation of a brand new node, there's no historical data to go back to build models. Most of the model construction in real networks has to be done via exploration in the real world. So lots of reinforcement learning interest. And explainable AI is very important as well, since from my background perspective, we're automating and helping some of the human engineers that have been doing this work for years. And every human engineer in every cellular network or even military deployment has to be able to explain what they did, why they did it, what was the outcome. It can't just be a black box. There has to be some explainable outcome. So I also have interest in explainable AI. That's sort of my background and interest.
You mentioned that things you were doing years ago in the Air National Guard or AI, maybe they weren't talked about that. But there are folks, perhaps more generalists, who think that AI is a new phenomenon in machine learning, but it's not new. Is that correct? Just like a lot of folks who may not be experts in spectrum, and spectrum sharing is a very big topic these days, has been for years. There's been spectrum sharing for decades. And so AI is not new. Is that fair to say?
Yes. For example, spectrum used for the Air National Guard deployments, that was coordinated by humans, oftentimes months in advance. Now we're talking about 5G, 4G and 5G networks that have to replan their spectrum and maybe even use shared spectrum on the fly. You take the material off a truck, power it up, and it has to find the spectrum to operate it. Without all of that lead time and human intervention, that's just one example of where the things that we were using human intelligence to do slowly have to be done much faster now in these dynamic new technology environments.
We want to talk generally first, and then we'll drill down on more details. What are some of that you all haven't mentioned, the potential benefits of using AI in network design that perhaps hasn't always been the case for either one of you, if you want to start?
So it allows us to predict the performance. So rather than being very reactive two things. One is not everything in the real world is strictly modelable. And so when we have to work in a place where there is not much models that will fully define and explain how we can change the parameters, it's really useful to learn things on the fly, as Arthur also pointed out. And we can be a little bit more proactive in our design instead of waiting. So one of the things that we used to do before is sort of react to what's happening. We see that the packet losses are really growing, and then we reactively change our protocol and so on and so forth. So we wait for that feedback, but we can now predict ahead of time using these techniques, and then that should generally work much better than reacting to the scenario. That's one way. We can use the explainable/interpretable angle to also study different types of attacks, and we can get a little bit, of course, with respect to security and things like that, it becomes a sort of cat and mouse game. So as we get better at detecting these attacks, then someone else is getting more sophisticated at doing these attacks. So that's probably always going to be a bit of a game, but we can generally up the ante using AI.
So in traditional cellular networks, the radio designs are done using oftentimes very detailed environmental information, building databases, terrain databases, sometimes with very, very high resolution. It generally in areas that where a license is owned by a cellular service provider in advance. And so they invest in all of this data up front, knowing that they can focus their energies in that location. That works relatively well in the cellular environment, but I envision military deployments where the location of the radio network deployment may not be known more than a few days before it's actually deployed, an emergency situation or a combat situation. In those cases, access to high resolution data for proactive design could be quite limited. Even knowledge of understanding of where cell sites could go may not be available until they actually get on the ground. So the role of AI in those cases, I think, would be to explore an optimal design given unforeseen conditions that are only experienced upon arrival at the given location. So one example may be that 10 base stations may be deployed, but there's only space for 5 of them in the given location. So any sort of radio design done with 10 base stations has to be revised again, or 10 base stations are deployed and 5 are destroyed somehow. The network has to redesign itself, fill in coverage, optimize the antennas to fill in coverage of the missing sites. And that, my observation, is something that has to be automated. And AI allows us to learn from changes made at one site that may benefit other sites versus exploration one at a time manually. That's the sort of thing that even in the early 90s, when Air National Guard deployments, we had to figure out how to make do with fewer bases. And we did all of that work manually, but just imagine a network that reconfigures itself as things happen. That, to me, is where AI is most needed.
Let me remind our audience to submit questions in the chat box there. We'll have our panelists answer them. Folks have said that spectrum efficiency, AI can be beneficial in spectrum efficiency, also areas such as providing services to people who are disabled. Are there any examples that you all can cite, or could AI be good in those two areas as well?
Yes, although I don't know if it's directly connected to spectrum per se, we have been working on, I've been working with another team that does biomechanical engineering type things to study how, an injury affects a person, and figuring out AI-based controls and AI-based explainability to sort of understand this mechanism of getting back into the workforce, or even making the workforce a little bit more friendly to a little bit more friendly to a person with disabilities. Like, what would you do? Like, we assume that certain ways, certain modalities are good for persons with a disability to train or to make them more comfortable in whatever day-to-day jobs that they have to do, physical jobs, for instance. But that might not be. So, for example, giving a lot of feedback, we think might be good to change their, to immediately change their body positioning or whatnot, to work on their thing might be good, but too much of that kind of information can be cognitive overload. So how do you balance these two things, right? So that's kind of thing we need to think about, and then figure out how an AI engine can be built to sort of learn this optimal space where the person who is recovering from injuries, or person who is working with certain limitations in their movement, can adapt to the situations. So that's the kind of work we're pursuing with some collaborators.
Okay. And then Art, as far as spectrum sharing, AI can be helpful in this area as well, I assume.
Yeah, it could be used to identify let's say opportunistic scheduling, to make use of spectrum that is let's say inconsistently used or sporadically used, and for example, identify patterns of use for some other case, and identify gaps that could be utilized for the military 4G or 5G use. In the people with disabilities case, I sort of look at some real examples from Air National Guard days where a piece of equipment malfunctioned. The expert for that equipment was not available to work on it. Someone else was there, and they needed remote assistance to troubleshoot and diagnose and resolve the problem. And so I can imagine, Ericsson's in the connectivity business. So I could imagine these networks connecting devices like VR glasses between an expert technician and an inexperienced technician, and using those sort of links to allow the expert to help the inexperienced person get the job done. And in this case, the AI for the networks case would be to identify the best use of resources to deliver that sort of service reliably. Experiment with different configurations and even different frequencies that satisfy the use case, and know during the use case if it is actually being satisfied or not. That may sound relatively simple because we're used to adjusting knobs while watching our TV screen, but imagine machines that have to do these sort of adjustments real time during transactions, and verifying that they're actually improving the transaction and the process. I consider that a really important case in military situations, because you have equipment deployed in lots of different places, and you may not have enough experienced technicians, for example, to maintain it all. You have to find the optimal way to make use of the resources you have. And these networks have to provide connectivity between those people reliably.
Well, the benefits or potential obstacles to deploying AI for networks, civilian or military, are they mostly the same? Because you specifically mentioned, Art, the need in some cases with either military, National Guard, the need to deploy instantly, basically that weekend, as opposed to, as you said, working for a carrier where you might basically be working on something that will be realized 2 years down the road. How would the two of you compare the benefits and obstacles of military versus civilian use of AI in network design?
Do you want to go first, Art?
Well, thank you. As I mentioned, in the National Guard, we deployed over weekends and tore down networks over weekends, which was a much faster pace than the commercial cellular networks. The commercial cellular networks need automation for a different reason, right? They want to improve the quality and efficiency of all of these deployments, make sure that assets are deployed where they're likely to make the most money and cost the least and deliver the best performance. And in these sort of remote deployment cases, the automation may be prerequisite for any sort of practical deployment now. So I think the automation is needed in both commercial and military, but for very different reasons. There are other opportunities that are used for different reasons as well. For example, in the commercial cellular networks, we have massive MIMO and beamforming antennas, requiring artificial intelligence to track the devices to the appropriate antenna in the most battery efficient and interference limited way. Those same capabilities could satisfy different purposes for military applications. For example, in the commercial networks case, we're serving devices that may get charged once or twice a day. In military applications, these devices may not be charged for days or weeks. So we have to be very, very battery efficient, and massive MIMO and intelligence to automate massive MIMO behaviors is important. In military cases, the radiation emitted by cell sites and devices has to be limited as well in order to reduce exposure to munitions that are radiation sensing, right? So the massive MIMO narrow antenna beams create a smaller aperture for that sort of detection. So there could be some opportunities there as well. In the commercial case, the narrow antenna apertures and massive MIMO beamforming, they're used to reduce interference. In military cases, it could be used to reduce the radiation footprint and detectability.
So I would like to add over what Art was saying. I would also like to add the fact that in military applications, there is no very reliable backbone. So you're doing a lot of ad hoc things, and so a lot of these things that are doing the edge and fog kind of things are more important, and the ability to set up and tear down these connections very quickly is important. Also, if you're doing things like federated learning and you want to learn from these nodes and you're trying to converge to some kind of optimal solution, some of these nodes can just die, or they can be compromised and cannot be relied upon anymore. So then suddenly you have to deal with the fact that your reliance on some of these nodes and the data that's coming in from those nodes is just not there. And then there can also be it can also be in contested spectrum. You may have other problems like eavesdropping and problems like different sophisticated types of jamming and more malicious attacks on your network. So you would have to also deal with those kind of aspects in your design and be adaptive quickly.
Okay. Just a reminder to our audience, if you have questions that you either want more answers from what we've discussed or things we haven't discussed, please put your questions in the chat box and we'll answer them. A couple of years ago, the FCC had a workshop on AI and machine learning, and at that time, the chairman of the FCC was Ajit Pai, and he said that he doesn't think regulators should dip their toe into the regulatory water, so to speak, because it will thwart the development of AI. I'm curious if either of you have a view on whether regulations will hurt AI or whether they could help AI.
So I was also named a Jefferson Science Fellow, and so although I am not an expert in regulations or policy and things like that, I do have some exposure. I spent 1 year at the State Department working on AI, ML, IoT type policies, and one of the things I got from that is that our government generally does not regulate technology until something needs regulation, as in something happens that requires the regulation to be in place. So that's our general approach. And in a way, one can argue both ways, I think, for this. I can see why you would do that, because if you try to put too many stops and blocks for technology, we may not be able to do it, but somebody else is going to do it. Some other country is going to do it, and so you have that thing to think about. That said, with AI, there is a lot of thought now going on about trustworthiness, about fairness. These are real concerns that really needs to be taken into account. And then I think about, okay, now is this going to be government regulation or something else? We don't yet know that. But there are lots of companies that are forming consortia to come to an agreement that an AI would do X and Y and Z, will have a minimum level of transparency, a minimum level of fairness, a minimum level of, lack of bias, and so on and so forth. And so that's kind of moving in the general right direction, I think.
We do have a question from someone saying, could you share some AI ML use cases around Sdn and Nvv, NFV?
So if you interpret software-defined radio as cognitive radio, then one of the things that very immediate use case would be spectrum sensing and trying to understand the spectrum profile, spectrum use profile in an area. So especially if you're doing a military type thing and you want to go in there, you want to figure out what kind of spectra I can use and how it is, trying to find that in the old, like when you have to sense it and it's not just available for you in some table somewhere. Then you can do this sensing using a lot of different nodes. And then you kind of, again, you can use federated learning type ideas or certain type of generated adversarial network type ideas to see how best to piece this picture together without doing too much communication overhead between these things. I'm not entirely sure what the other abbreviation means. So if the question.
Okay. The other issue is, and I think we may have talked about this when we planned this call. Some folks have suggested the government can at least help set standards to make data available, because these data sets can be very helpful, and it's hard to get the data when it's proprietary or owned by certain parties, or at least the government can make all the data it has collected itself available for researchers and others. And I'm curious if either one of you want to talk about whether that would be helpful.
I had some feedback on this. Standards have been, crucial for all Gs of networks since the beginning of cellular, and there's no question they'll continue to be really important. But my observation is that a lot of innovation in this industry has occurred with beyond standards exploration and work. So don't wait for the standard to explore some additional opportunity for learning and automation. And I see standards as something that may be considered if their absence is otherwise limiting progress. I think the government could help, not by setting standards, but by setting some very demanding use cases, perhaps like some that we discussed here so far, that force the industry to think about how to implement those sort of use cases, sort of the real-time network redesign and reconfiguration, and maybe even some sort of a mesh network automation requirement that would force the industry to think about and prioritize the data, the automation, the compute horsepower required to do those sort of things. And then I think if the industry finds that standards would help make those things happen, then the industry themselves would drive the standards. I think from this perspective, what I'm saying is I think the government might be better off providing demanding use cases than regulation.
Okay.
So I have a perspective on that as well. So again, our government does not do standardization, unlike certain other governments. But as a university researcher interested in this area, I find this lack of a standardized data set to be an extremely limiting factor. We don't have an MNIST kind of movement here in this wireless domain and cognitive radio domain. So independent research like that's very hard. That said, NSF and, mainly NSF, has put in a lot of money and thought and effort in trying to fund people to create data set that they can then, distribute for free for everybody else. So I think that's a great step in the right direction, because having that kind of independent data that is accessible to university researchers will definitely push this whole thing forward.
There's also been concern that AI could compromise data privacy. And the question some folks have is if people are worried that privacy will be compromised, they won't have trust in AI. And if you don't have trust in AI, then folks will be reluctant to follow it or to observe it or to agree to it or to support it. Either one of you want to comment on that?
Sure. The trust in AI thing, I think, is a much broader conversation. It also includes fairness. It also includes a sort of transparency, a kind of explainability. Why did this AI decide this is what it wants to do? Because that can lead us to some very important things that we didn't realize, like as engineers that built that AI, thinking this is what we are building, and then you find that the AI is making this decision for all the wrong reasons, making the right decision for all the wrong reasons. We want to know that. So for all these things, explainability is an important thing. With respect to data privacy, yes, so when federated learning started, it was kind of, everybody was very excited about it because that it had a way of doing distributed, like you can share your data without worrying too much about your leaking privacy about your device or your information and so on. However, even with that, there are some holes that people have found, and it's an active research area. There is a whole topic of privacy preserving communications and privacy preserving learning and so on and so forth. So that work is being pushed forward. So it's not, in any kind of communication, you might have that leakage. It's not very specific to AI, but the good news is that a lot of people are thinking about it and thinking how to solve it.
This concern of this privacy concern is being addressed in a number of industries and primarily being addressed, as Suba mentioned, with federation and edge computing, and TinyML, for example, is another example where data is collected and analyzed and worked on at the source instead of being transported beyond the source. The opportunity to work with raw data, for example, including private information at the source, has a number of benefits in addition to privacy. So from a privacy perspective, if we convert the data into a model or an insight before sending it elsewhere, then it's in effect anonymized and not revealing private information. But there are other benefits, including latency. Processing data at the source takes a lot less time. Cost, transporting data from one place to another for artificial intelligence functions or otherwise, cost a certain amount of money. There's a data transportation cost associated with that. Energy is another opportunity that's improved, or a situation that's improved with local versus remote processing. We're expending less energy transporting lots of data over longer distances if we process the data right there at the source. So the privacy aspect is very important for the whole industry, but the good news is there are time, energy, cost efficiency, and even robustness opportunities with edge processing that are driving industrial action in this area. In terms of robustness, if raw data is processed at the node, then if links to the rest of the network, for example, the core network, remote core network is broken, the node can still function. The node can still process data, perhaps do inference, perhaps do some form of learning and adaptation without connection to some central cloud entity. And in military applications, I think it's important because connectivity to the outside world may be impacted by events, unplanned events. In cellular networks, these links have to be, 5 nines or 6 nines reliability. So we worry a little bit less about that robustness and autonomous requirement. But in military applications, I don't think 5 nines is a practical expectation, right? We have to have nodes that can function on their own if they're disconnected from the outside world. And so again, that's just another driver for working with the data at the source, in addition to privacy.
Okay. We have another question from an audience member. Keep the questions coming in the chat box. The best question gets a beamforming prize from Art and Ericsson. All right. What is your opinion on the amount of AI autonomy, especially for critical systems? Or is a hybrid approach the way forward with user intervention at key points in the system process?
Is this question for me?
Either, but you can start if you want.
Okay, I think as I mentioned, I think it's very important for nodes to be able to function autonomously when required. But in cellular networks, including commercial or private cellular networks, each base station is contributing to an environment where there are signals and interference. And the need to coordinate between base stations is very important for maximum efficiency, even spectrum sharing. But we also need autonomy if the link between base stations is broken. So I would say that a hybrid approach is really what we need, and it should be conditional. It shouldn't be a rules-based approach. It should be if a coordination link is down, then the node functions autonomously. If the coordination link is up, then we maximize efficiency with multi-node coordination.
I would concur.
Okay.
Yeah.
There's also a concern that some folks have in a lot of industries, including journalism, that AI will lead to people losing their jobs because you can accomplish things with fewer people. Is that something, do you think, that will occur in the tech space and telecom space with AI and network design, for instance? Not asking you to predict, but is that something that could prompt some resistance, if you will, from the bottom up to AI?
So yes, I've heard that comment several times before, and what I would like to offer in order to restore the perspective is that this kind of comment was done for the regular computers. It was done for when computers came out, when the Industrial Revolution happened, and for everything. So what might happen is some jobs will go away for sure. But people will be retooled, and a lot of new jobs will be created. Things that there's probably going to be someone that needs to do the types of AI engineering that now will become something like routine maintenance, but something that is not going to be some other AI's job. So there will definitely be a completely different set of opportunities that are going to be created. just like it has happened with the Industrial Revolution, just like it's happened with regular computers, right? So
I agree with Suba. Without AI, 4G and 5G network deployments were limited to large cellular service providers that built, these nationwide networks with dedicated spectrum, and they provided pretty much plain vanilla services to all of the devices and users that they served. With AI now, more things are becoming practical. For example, we can provide network slices for individual industries and individual users that creates a whole new industry of connectivity and use cases that were never possible if every single one of those slices had to be manually configured. With AI and automation now, companies like Ericsson can make products that are getting to be as easy to configure as a Wi-Fi access point. So now private networks are becoming possible. So instead of having a customer base and an employee base of only working for the cellular service providers, now different industries are investing in their own 5G and down the road 6G networks. And I think that's expanding the industry, not contracting the industry. It's expansion that's enabled by artificial intelligence, not contraction that's caused by job loss associated with AI.
Is that good for companies like Ericsson because you can have that potentially more customers? For instance, the FCC, they auctioned the Citizen Broadband Radio Service. They had hundreds of people bidding in that auction, which has never been seen before. Many non-traditional folks, utilities and other folks, that schools, universities that we had never seen before.
Yeah, the combination of plug-and-play networks and shared unlicensed spectrum just opens lots of doors for industry expansion. You imagine an IT manager for a company now managing their own private 5G network because it's automated enough to where they don't have to have a huge staff of radio engineers and developers. It's the democratization of these networks enabled by AI that I think offers more opportunity than risk.
Now, we talked earlier about privacy. I think Suba touched on security. Do you want to elaborate at all on the security challenges with AI?
So for example, there's a whole slew of security challenges in cognitive radio networks that are sort of, I like to think of them as not quite denial of service, but rather degradation of service. So there's a whole set of different ways of doing this at the phi layer, the MAC layer, and so many different ways if you want to think in those terms. So all of these attacks can become more pronounced or easier to do with an AI. Like you can do things like data poisoning attack, and your entire machine learning algorithm will learn all the wrong things. So you can make it so machine learning things all depend on getting boundaries between decisions. So you can move those boundaries around in such a way that you're not detectable, but the machine is making these errors. So that can happen in various ways. So when you design your AI, you would have AI engine, and if there is propensity for this sort of attacks to happen, like if there is a way that this attack could happen, you should sort of proactively design with checks and balances in place so that you can deal with it in some way. So that would be the broadest way of talking about it.
From a network security perspective, I sort of see an opportunity with AI because in many cases, for example, denial of service attacks, manual processes to identify and locate and mitigate a denial of service attack are relatively slow and cumbersome. I can remember cases where a network node would go off the air, and when we restored it back to service, all of the devices in the area would try to attach to the network all at the same time. And that looked like a signaling storm, which is very much like a denial of service attack. It's an unintentional denial of service attack. So we created these manual processes to throttle the signaling, a cell site at a time. We manually planned which one do we turn up first and next in order to prevent all of these upstream signaling storms. I think machines could learn and adapt to that sort of a situation much faster, absorbing the location and source and pattern of signaling storms and moving them over into throttled areas to mitigate the impact to the rest of the network. Many cases, it took us hours and nights, and we called it pizza time because we'd be stuck in switch all night long trying to deal with these things. If you look at what was actually being done, I think a machine could detect and adapt to those conditions much faster. So to me, I see from a security perspective and a network robustness and reliability perspective more opportunity than risk today.
But suppose you had a situation, you had a Chinese vendor like Huawei or ZTE, and does it open up that many more opportunities for mischief, if you will, if you have these vulnerabilities and they're not addressed up front, and you have, let's say, companies that have a foreign power that's hostile to the US behind them, is that just another front, if you will, for cyber vulnerabilities in the world of AI?
My observation, and this has come up in a lot of different forums, is that the more automation, the more intelligence, the more speed we add to making network adjustments, the more risk we have that machines may actually make mistakes and conflict with each other faster. And to me, the answer to that is not a security question, it's an integration question. We have to make sure that all of these AI ML functions that are touching the common network are all working together in concert and not in opposition. And I don't know that it matters the source of the software, intentional or unintentional. If machines are not synchronized, there's a significant risk of conflict, and that has to be addressed via integration up front.
Either, as we talk about network design, can AI be useful either in helping a provider find network sites or in basically predicting the availability of what spectrum they're going to need?
Yes, it can. In especially if you're going to a new area, like in military communications and things like that, it is definitely something that you can learn using AI, just like the other problems of spectrum mapping and things. But now it won't be just this occupancy, it will be a whole bunch of other factors involved as well.
Okay. Okay.
So a lot of the military equipment that I worked with when I was in the National Guard was mobile. It was on wheels. So I could imagine that to cover a given area, whether it be an airfield or some open area, they deploy 5 radios, and they have to identify what's the optimal location for each of those radios, assuming each is available. So that could be automated, not necessarily requiring artificial intelligence, but automation would be quite helpful. And the next question is you design and deploy with the 5 nodes, and 2 of them drop offline for some reason. You have to reconfigure the remaining 3 to acquire the optimal outcome. And that's another opportunity for AI, I believe. In the commercial site or network case, predicting the viability of a location, it's something you might be able to predict some aspects from the outside, but ultimately my observation is the person willing or not to have radios on their rooftop? Are they willing to negotiate? How much is it going to cost? Those are things that those are data points that I don't believe are really accessible to most AI functions. There's always that human element in those commercial cases where the best site may not have a willing landowner.
Right.
How do you predict that with artificial intelligence?
We have a little under 10 minutes left, so if folks want to submit some questions in the chat, we will get them answered. And it sounds like, Art, when you were working for the International Guard, what you all needed was FirstNet, but there's no FirstNet then.
No, I was working with FirstNet while at AT&T.
Okay, all right.
And FirstNet had a lot of deployable requirements and the need to turn up cell sites on the fly for certain emergency situations. Some planned, some not planned. FirstNet, I think, is sort of a mild example of some of these military deployments that I can remember in the National Guard.
Did you all have, although they might not have been called that back then, Colts and cows and things like that?
Yes.
Okay. Did you have a balloon? FirstNet's got their own blimp now. That's helpful. Sometimes.
That came after I left. That was pretty cool. I would have liked to have been involved with that. I think Google used balloons over Puerto Rico after one of their natural disasters. I think it was Project Loon.
Mm-hmm.
I think that was one of the first large-scale use cases.
Let me ask Suba, we had talked earlier about the access to data. Is there anything we didn't discuss or I didn't ask about any other ways to get access to that data because it relies, the AI obviously relies on big data, relies on a lot of data. If you don't have it, it's really hard to crunch those numbers that help you get to that efficiency, if you will.
Yeah, it really is. Having not just data, but properly labeled data is tough. It'll be nice even to have, from a security perspective, trying to have data when one of those cyber attacks happen or attacks on IoT type systems. Those would all be great, but I don't know that that would be shared because those are generally proprietary. And perhaps what we would, perhaps the question I would ask is there any interest for industry to collaborate with university researchers on projects such as these? I don't know if it's a fair question, but it's a question that I have.
Now you're also a professor, is that right?
Me?
Yes.
Yes.
Is how you do your job and how you teach it and what you're teaching much different than it was, let's say, 10 years ago, because of a lot of these things that maybe they've been around, but they have not been in the forefront?
Yes, it's a lot different. So the way I teach, I have to say I have not, well, in some ways I have changed, in some ways I have not changed. I have steadfastly resolved not to use slides in my class, so I still use a chalkboard and write. But that's basically because that's for the mathematics part of it, like where you have to deal with, and I personally believe that engaging in 3 different things that are all about learning makes that learning experience much better. But of course, the way we teach, in certain ways it hasn't changed in that I used to give programming assignments for things that have to be built, like systems that you mock, systems that you build so that you learn those things and what it really means. Now it just is all done via a bunch of AI platforms that you can get and programs that you can get. So the students aren't exactly programming an entire explainable AI work. They can get a whole bunch of bits and pieces from GitHubs and so many different places, so that effort is not there for them. So you can really do a comparatively much bigger project for learning than they can if they had to write every single code by themselves. So those things have changed. Yeah.
So then when they get out, will they only be required probably in their jobs to do what they've learned from you, or they have to do more than they learned?
There is almost always an on the job aspect of on the job learning aspect for anything they do, and I'm talking about those who go to industry. And if you actually think about me, even if you're going into academia, I think you're not staying with that exact same research area with which you graduated. I have changed my own research area so many times, typically once every 5 years, I think.
There was no edge when 25 years ago people didn't talk about the edge, and now you said your research focuses on the edge.
Yeah. So I think as a professor, I think one of my biggest jobs is not just to teach students the subject, but teach them to learn. Because no matter what they do in the end, not everything that they learned here is going to be relevant forever, or at least not in this form. And they're going to have to learn to adapt.
Mm-hmm. We have time for one more question if anyone would like to ask it. I guess not. So we're going to pass it back to David now, and we thank you for your insights.
Thank you very much. So that will conclude our tech talk on artificial intelligence and network design. On behalf of the entire National Spectrum Consortium, I'd like to offer our deepest thanks to the moderator and the panelists today. It's really given us a lot to think about. Also, I'd like to thank the attendees for their participation, their questions. If anyone has any questions about NSC, feel free to reach out to me or any other member of the Executive Committee. Also, be on the lookout for information on the next Tech Talk that will have a focus on spectrum sharing and usage. Thank you again and have a wonderful day.